Hello, Keegan here from Curious Engineering, doing a follow-up video from the introductory video on Altera and Quartus Prime and FPGAs. So let's kind of jump into the scope of this one. What we're going to be looking at is how do you get more involved. It's kind of like your entryway into FPGAs and have that development environment. So, oh, you can't see my mouse. Okay, so the university program is a great way to start. In order to get there, though, just go to your altera.com site, go to support, and over here in the training section, you'll find the university program. Alright, so we are interested in the materials and the laboratory exercises. So they have a few different offerings here. You can do your digital logic series, you have computer organization if you want to look into some C and assembly stuff, as well as some embedded stuff. So let's start with the digital logic. It's probably the best place to start, and you can see that there's a number of different labs in both Verilog or VHDL. So the ideal candidate for this university lab or the university program who might have had some exposure to digital logic and logic design, but definitely by no means a requirement. You'll learn some of those things, or you can find another like textbook reference to help you kind of go through some of those things if you don't know what the components or logic elements are. So let's go ahead and download the PDF. So once you download the PDF, you should just open it and kind of gives you an introduction onto the scope of lab exercise number 1. We're going to start with part number. Oh, you probably can't see that too well. Let's jump over here. And you'll notice right here they have a number of suggested boards, development boards that they recommend: the DE0, DE1 SoC, or DE2-115. So what boards are those? If we go to Turasic, that's the main company that offers the complete boards for you. You can find other ones, but this is definitely one of the better ones. Let's go to Cyclone 5. So you saw that they recommended you have the DE0 Cyclone 5 board. It's a little bit more affordable, a little bit more basic, but it should do everything you need to. I actually opted to get the DE1 SoC board, especially because I wanted to complete those embedded or computer organization series and get a little bit more into it's an SoC, so you're going to have a microprocessor as well. So a little bit more expensive, but a little bit more capability. When you're here, though, let's kind of look at some best practices and that will help you kind of navigate this realm. Go to your resources from Turasic, and right here you'll see you have a good user manual. Yeah, I think I have it here. So yeah, so user manual goes through a lot of different things, getting everything set up as well, which I probably will do in this video, but it's a great reference to have. What you'll notice though is there's these different revisions, and they have a little section here they'll teach you how to find that. But if you look at your board, right in the top corner here, it's really faint, but it will identify your revision, and I would just go there. So again, yeah, I have the DE1 SoC. One best practice too, they're going to ask for your device identifier, kind of like your specific one you're going to be targeting, and it's great to just have that labeled or on hand somewhere. So do yourself a favor because you're going to be entering that number quite a bit. The next thing I want to go through is the device CD-ROM. So once you figured out your revision of your board, go ahead and download this CD-ROM. It'll have a number of different things on it. I'll kind of just go through it a little briefly. So once you download it, I'm going to bring it over here. You can open it, and it has all the different manuals. It has some tools in there. We'll go through the system builder specifically. We don't need to do it right now, but that's another useful tool that when you're reading through the user manual, they'll allude to it quite a bit. Different data sheets. So there's a bunch of different things. It's a great thing to have. So make sure you download that. Okay, so let's create our project. So open up your Quartus Prime. You'll want to do just the new project wizard. So it's going to ask us, give us an overview of what we have to go through. Now when you're creating a project, you want to make sure you're in the correct location. So before you start, I would recommend creating like a projects folder within a low-level working directory. And what I mean by that is don't bury it very deep. This is a recommendation by one of my professors who works at Xilinx. When you have an FPGA project, there can be issues if you bury it very deep. So I'd recommend kind of in your main Quartus Prime folder, maybe create a project and then just a one more level beyond that. So just, I guess, takeaway, just don't bury it too deep. Now, what do you want to name this? Let's name it Lab 1 Part 1. You can name it whatever you want, but just make sure you take note of the name of the project, because that will be important when you're adding your Verilog module, your top-level module, as well as naming that file. So, okay, now we've done that. We're going to do an empty project because we don't need to do anything too crazy here, so we'll start with the basics. We're not going to add any files. You can have that option if you want to. If you already have the Verilog files, you can add those at this point. In this case, we're going to create our files. Now we just need to target our device. So for me, I do have the Cyclone 5 board, the DE1 SoC. So make sure that's selected. And what you'll see is there's a lot of different devices, right? So you got to target the correct one. That name or that specific device will be on the chip itself, so you can go there. Or like I said before, you can just save yourself some time. Just have that reference ready. So just make sure you type that in. So I'm doing mine right now. Make sure you do yours. So I've typed the whole thing in, and we want to make sure it's selected. So it's done. Now it's going to ask about some different tools. We're not going to use any in this case. So just hit next, and I'll give you a summary. Have our correct target, so we're looking good. Okay, so the first thing you want to do is you want to add our Verilog code to this. So make sure you're looking in your files, and you can either go File New, or there's the New button here. So let's add a new source. We're going to add a Verilog file. And if you look at the lab file, you can copy and paste from here, but just take note of this name here. If you changed whatever you named your project, you want to make sure that that name is in the module as well. So just take note of that if you're copying and pasting. For me, I've already written this, so let me just copy and paste that over here. Okay, so again, I have named my module Lab 1 Part 1, which matches the top level. And then now let's make sure we save this, and I'll kind of walk through what's happening there. So I'll save the same name as well. So kind of reiterating that, but that's really important. You'll have some problems if you don't do that. Okay, so what is this doing? So this is our top level module. This is just saying I have input switches, switches 0 through 9, and I have the outputs. That's what I want to be the LEDs. So you might be wondering, like, why did I choose, or why did they choose switch and LEDR? If you look at your user manual, so I just know the page, so I'm going to enter it. They have specific names, I guess you would say, or variables pre-created. So this is where you would find what those are for the switches, for example, and then for the LEDs, so they have them listed here. If you haven't used Verilog before, then this might be a little confusing, but essentially what we're doing is we're creating 9 different switches by this notation and 9 different LEDs. And then we're assigning, so we're saying, like, whatever switch we have, switch number is active, make sure that that LED is also active. So that's essentially what this assign statement is. So this is, what is it? Is it behavioral? I think it's behavioral. Verilog kind of level. But anyways, let's move beyond that. So once this is done, let's go ahead and do something wrong, and then we'll see what happens, and then we'll walk through the assignment portion of this. So go ahead and run this. Yep, save your changes. And so it's going to run here. So this is how you keep track of your progress. Let that go. I might cut and fast forward for you so you don't have to watch this. Okay, so it's completed its analysis and synthesis, and already we have some warnings here. So you'll want to take note of those. The one in particular that's going to stop us from actually being able to do anything is a critical warning. So this is saying we haven't assigned our pins, so it doesn't know what you have this code, but nothing is targeted to the correct location. So we need to do that. So when this is done, okay, so it's done. It won't allow us to progress. You got some warnings, so we want to make sure we address those. So in order to do that, following the lab, it says make sure you have your pin assignments, so we didn't do that. So this is good. This is telling us that we can't continue. So we need to do that. So what you can do, there's two ways to get to your pins. You can go to pin planning here, or the button is also, assignments. Go to your assignment editor, or you can go to this button here. Alright, so this is where we need to make the assignments. What you saw in the user manual is, for example, switch 0, that actually has a pin reference of pin underscore AB12. So we need to clarify that in order to make sure that everything is hooked up correctly. So first things first, this is a really slow way of doing it, but if you need to do it or want to do it this way, then you can. I'll show a faster way. So as the assignment, we're going to actually say it's a location. Okay. And if you're confused about this, what the lab will actually point you to is the place to go. I don't know why this is. Okay. Here you go. So they recommend going to the Quartus 2 Introduction guide, and that will also guide you through the assignment process. But we're going to just do it here. We'll do it one manual. So now we're going to you'll click here, and this is where you define what you are going to have. So make sure you have all pins here. You'll hit list. It's going to find those according to your Verilog code. So let's start with the switches. So you would do switch 0, for example. Okay, it adds it there, and now we need to assign it a value. So that was pin AB12. Okay, you get a green check. That means things look good. You can double verify switch 0 pin. Sorry. So I'm trying to do one thing. Okay, never mind, screw it. So yeah, pin, that's correct. So you have to do that. If we have 10 switches and 10 LEDs, you have to do that one by one. That's really repetitive, so let's do a faster way of doing this. Let's look at what's known as Quartus settings files. So those are .qsf files. And what those look like, bring this over, is it has everything already pre-set up for us. So you have all your locations with the pins and the names as well. So for example, let me scroll down to it. Give me a sec here. Okay, so here's all our switches, and you can see it's in the switch section, and then above it is all the LEDs, and it has that. So let's use console commands to expedite this, but then there's also one more thing that we can do that's kind of handy. So if you actually you can select all of them and then go to your console. So again, you can go to console and just copy paste them. Cool, look, bam. So really easy, it already does it for us. Makes life easy. And then let's make sure we do our switches. Okay. Awesome. So we have 0 to 9 LEDs, 0 to 9 switches. So we're all good here. So this is good. So let's recompile. While that's happening, I'm going to talk through one other thing. So we'll let that run. You might be wondering how I got this file. So there's a few different locations to find it. If you go to your Altera site, go again to support, university program, and if you go to boards, they have a number of different boards. So there's your DE0CV board, and then my DE1 SOC board. So this is really handy to have, and you'll see this file, this QSF against a Quartus setting file with pin assignments. That is what will come up, this whole file of all those pre-assignments from that location. The other thing that we did, and I'll refer back to this one or kind of go back to it since we mentioned it earlier, the CD file that you downloaded from Teresa from this site, this CD-ROM with all your different options on it. Let's go into that real quick. Let's look at the tools, the system builder. I alluded to that before, but this is another way to get that QSF file. So this is a neat application, and what it's asking for is just like, what elements do you want to use? You'll see that, like, I want to use the 7 segments. So if we only want to use the 10 LEDs and 10 switches, this will actually generate that for us. It's just another way of doing it. So it's kind of a handy tool. So select what elements you're going to use and then say generate. Should pick on my desktop. Okay. And there you go. There's your QSF file with just... Oh,
I don't understand.
I'm not talking to you, Siri. Okay, so there you go. So there's just your LEDs and your switches. So that's another way of doing it if you want to use that route. But you could also... I hate having things on my desktop. You could also, again, go to the Intel site or Altera site. Either one. So multiple different ways to do it. Okay, so now we kind of talked a little bit about assignments while I was letting it run in the background. It looks like everything completed successfully, so that's great. Let's double check to make sure. So 6 warnings. If we check out what those warnings are, so it's saying we don't have clocks, which we don't need clocks in this case. So we're actually pretty good here. So let's continue on and actually program our device and see it work in real time. So just make sure you hook it up. Again, you'll want to use like a USB A to B cable. So you'll want to plug into that port, and then just make sure you have power. And then hit your. It'll turn on. It'll kind of go through its own little pattern. It's just automatic. It will do it on its own. So don't worry about that. So now we need to actually just program it. So let's just do it. So you can go to Program Device. You can double click here, and it will open a different window. So we can actually program, or you can also go to this button here, and it will get you the same spot. Okay, so now that we want to make sure you have the correct programming mode. If you don't see your hardware there, you'll want to go into Hardware Setup, and then look for your device there. And if everything probably will be okay, but if not, then just make sure it is being recognized by your USB port. So if you have something there, that's good. So now we want to detect it. So it will detect what is connected through the JTAG interface. It'll give you a number of options. Again, just remember which one you have. For me, this is the 5CS-E MA5. So it will create a number of different devices to target. So for us, you can add a file. We need to, once it's almost like your output file after you compile and see. There is a specific file that's the entire project ready to go, ready to be loaded onto your your device. So that's going to be under the output files, and it's a .sof file. So that's like a .o file or object. You want to make sure you have the .sof for the programming file. So you select it, say open, and it does this really weird thing sometimes. It almost creates a duplicate, but just make sure that your programmed one that has the check mark and the checksum and user code there, and just delete the excessive one. We're not using the hard processing, the HPS or the system on chip, so we're just using our FPGA. So once you get here, you should be ready to start, and you'll see progress. And then let's see if it worked correctly. So right here, all your different switches, when you activate them, the LEDs turn on. So looks like we're working correctly, so project's verified. Project 1 down, and let's move on to the next one. All right, thanks guys.